Hey everyone, welcome back. We've been getting a ton of questions about energy-saving tech lately.
Yeah,
And
definitely hot topic.
it seems like everyone's looking for the next big thing.
For sure.
So today we're going to dive into one of these companies that's generating a lot of buzz.
Okay, sounds good.
Hookom Energy Systems. Ever heard of them?
Vaguely.
Yeah.
The name rings a bell, but I haven't dug into their work specifically.
Well, strap in.
Okay.
Because they claim to have found a way to slash energy consumption by a massive 80%.
Wow, 80%. Now, that's a claim that'll turn heads.
Yeah, 80%.
That's not just, like, incremental improvement. That's a complete paradigm shift.
Exactly. And that's what makes this so intriguing, right?
Yeah, for sure.
I mean, imagine if we could actually achieve that kind of energy reduction. What would that mean for, well, everything?
It would be revolutionary. I mean, it would completely change how we think about energy consumption, resource management, the whole shebang.
So we've been digging through articles and research trying to break down their claims. Right. And it all revolves around this idea of harnessing the power of electron spins.
Electron spins.
Yeah, those tiny little electrons inside atoms?
Right, yeah.
Well, they're constantly spinning, and that spinning actually creates a teeny tiny magnetic field.
Okay, I vaguely remember this from physics class, but give me a refresher. How does a spinning electron create a magnetic field?
So it's a little complicated, but basically when an electron spins, it generates this sort of magnetic dipole.
Okay.
And that dipole acts like a mini magnet.
A mini magnet.
Yeah, it's pretty wild. Now imagine tons and tons of these little spinning electrons all lined up in the same direction, like in a bar magnet.
Gotcha.
Those tiny magnetic fields, they combine, they amplify each other.
Ah, so you're saying that's how we get those fridge magnets to, actually stick to things.
Exactly. It's the combined force of all those aligned electron spins creating a larger magnetic field that we can actually observe and feel.
That's really cool. So how does Hookom Energy Systems fit into all of this? Are they saying they can somehow extract energy from these electron spins?
Well, from what we've gathered, they believe they can manipulate these magnetic fields within materials to generate electricity.
So they're not creating energy out of thin air, but rather tapping into existing magnetic forces.
It seems that way, yeah. They're being very tight-lipped about the specifics.
Right, makes sense.
But they claim their system can produce, get this, 5 units of electrical output for every 1 unit of input.
Now, hold on a second. That sounds a lot like, we talking about over unity here?
Yeah.
Perpetual motion machine territory.
That's what jumped out to me, too, because, the fundamental law of conservation of energy tells us energy can't be created or destroyed.
Exactly. You can convert it from one form to another, but you can't just magically make more of it appear.
Right. It's like trying to get something for nothing. It just doesn't add up, does it?
Not in the world of physics, at least.
So that's the big question, isn't it? How does Hookom Energy Systems explain their claim? Are they suggesting they've found a way around the laws of physics?
Or are they maybe misinterpreting their findings? It's happened before.
Oh, absolutely. I mean, the history of science is full of examples of people claiming to have invented perpetual motion machines or found ways to cheat the laws of thermodynamics.
Right, and those claims almost always turn out to be, well, let's just say overly optimistic at best.
Yeah, more like completely debunked.
Exactly. There's always a catch. So with that healthy dose of skepticism in mind, let's dive into the proof Hookom Energy Systems is presenting. Have they released any experimental data or anything like that?
They have. They've highlighted an experiment where they compared plexiglass and electrical steel, and they observed a higher magnetic flux in the steel.
Okay, and they're claiming this difference in magnetic flux somehow validates their energy generation claims.
That seems to be the implication, yes.
I'm not sure I follow the logic there. I mean, electrical steel is known for its magnetic properties. That's why it's used in transformers and motors. Comparing it to plexiglass, which is essentially non-magnetic, doesn't really tell us much about generating excess energy.
It does feel a bit like comparing apples and oranges, doesn't it?
Exactly. You have to control for these variables to make a meaningful comparison.
So it sounds like they might be cherry-picking their data to support their claims.
It's possible. We need to see more rigorous testing and analysis to draw any firm conclusions.
Right, we can't just take their word for it.
Of course not.
But, this was all just lab research.
Right.
What happened when they tried to actually implement this technology in the real world?
The million-dollar question. Did it work?
Well, it turns out there was a company, B&K Energy.
Oh?
They actually decided to give Hookom's tech a shot.
Really? They were bold enough to actually implement it?
Yeah, they installed Hookom's devices in their facility in Delaware.
In Delaware.
Interesting.
And they were hoping, of course.
To see those massive energy savings.
Of course, who wouldn't? Especially with those kinds of promises.
Right. 80% reduction. Who wouldn't jump at that?
Yeah, that's a game changer, potentially. But I'm guessing there's a but coming here.
Oh, there's a big but coming.
Okay.
Because unfortunately for BNK Energy,
Yeah.
their energy consumption didn't go down. It went up.
It went up. Wait, are you serious? Instead of saving energy, they ended up using more.
That's what we found, yeah.
Wow, that's not good. Not good at all. That's a pretty big red flag, don't you think?
Massive red flag. I mean, it just goes to show that, you really can't just throw technology at a problem and expect miracles.
Right, especially when that technology seems to bend or even break the laws of physics.
Exactly. And it makes you wonder, like, what kind of due diligence did BMK Energy do before they went all in on this?
Yeah, that's a good question. I mean, were they so caught up in the hype of this potential solution that they overlooked some critical red flags?
It's possible.
I mean, we've seen this kind of thing before, right? Where a new technology comes along, promises the world, and people get so caught up in the excitement that they don't ask the tough questions.
Absolutely.
They don't dig deep enough.
And unfortunately,
Yeah.
BNK Energy, they ended up filing a lawsuit against Hookom Energy Systems. $5 million lawsuit.
Wow, so it really hit the fan, huh?
Yeah, it seems like things got pretty messy.
Understandably so, I'd say. I mean, if you're promised this incredible energy-saving technology and it ends up costing you more money, well, you're going to be upset.
Yeah, you're not going to be happy.
No, not at all.
But I guess it just underscores the point we were making earlier about being critical.
Being critical, yes, absolutely.
And really taking these
Claims, yeah.
with a grain of salt.
A big grain of salt, it seems like in this case.
Especially when
Especially
they sound too good to be true.
because, let's be honest, if it sounds too good to be true, it probably is.
Right.
We've learned that lesson time and time again, haven't we?
Definitely. But that doesn't mean we should just give up on innovation altogether, right?
Oh, absolutely not. I mean, we need innovation now more than ever, especially when it comes to something as critical as sustainable energy solutions.
Right.
But we need to be smart about it.
Be smart about it, yeah.
We need to balance that enthusiasm
Yes.
with a healthy dose of skepticism
Healthy dose of skepticism for sure.
and rigorous testing.
Absolutely. So even though Hookom Energy's claims
Yeah.
seem to have, well, fallen a bit flat,
A bit flat, yeah.
it does make you wonder, what if? What if we could actually harness magnetism in this way?
Right. What if we could unlock that potential?
What kind of impact would that have on the world?
I mean, it's mind-blowing to even think about. We could potentially solve the energy crisis overnight.
It would be revolutionary, wouldn't it? It makes you think about all those sci-fi books and movies
Oh, absolutely.
where they've got these like limitless energy sources powered by some kind of, magnetic mumbo jumbo.
Right. And it always seems so simple in those stories.
Right. Like, oh, we just figure out how to tap into this unlimited energy field. Boom, problem solved.
Yeah, but in reality, it's never that easy, is it?
Never. But okay, let's say, hypothetically,
Yeah.
we do figure out how to harness magnetism as this clean, abundant energy source.
Okay, let's play along. What happens then?
What happens to the world? I mean, does the energy crisis just vanish overnight?
Well, in theory, it could, right?
Mm-hmm.
No more dependence on fossil fuels, no more worries about running out of resources.
But it's not just about flipping a switch, is it?
Definitely not. There would be massive ripple effects throughout every aspect of society.
Right. Think about it. Our entire global economy, it's built on this foundation of scarcity. Right.
Exactly. Energy scarcity, resource scarcity, it drives everything.
Yeah.
So if you suddenly remove that scarcity, well, who knows what could happen?
And what about the environmental impacts? I mean, we're always told there's no such thing as a free lunch.
Right. Every action has a reaction.
So even if this magical magnetic energy is clean at the source, there's got to be some kind of trade-off, right?
There's always a trade-off. It's
Yeah.
about understanding those trade-offs, weighing the pros and cons, and making informed decisions.
So it's not just about, yay, free energy. We have to think about the bigger picture.
Always. We have to think about the long-term consequences, both intended and unintended.
And that's where things get really complicated, don't they?
They do. But that complexity, that's what makes these discussions so important, right?
Absolutely. Because if we don't ask these tough questions now,
Yeah,
then we might not like the answers we get later.
exactly. And sometimes, even asking the questions isn't enough. Sometimes we need to dig deeper, do the research, and understand the nuances of the issue.
Well said. So While the promise of free energy might remain elusive,
For now, at least.
this whole deep dive into Hookom Energy Systems, it's a good reminder to,
Yeah,
stay curious,
absolutely.
but also
Be skeptical,
be skeptical.
but think critically.
Absolutely.
And don't be afraid to ask the tough questions.
Couldn't have said it better myself. That's all the time we have for today. Thanks for joining us on this electrifying deep dive.
It was a fascinating one, for sure.
Until next time, keep those brain cells buzzing.